Hey guys, today we're going to be talking about theoretical probability, but we're going to cover some vocabulary before we get into any kind of math problems. So we're going to look at theoretical probability. And theoretical probability is that mathematical calculation that an event will happen in theory. That's the big part right here, in theory. So in other words, if everything in life was fair and equitable, what would be the chance of, like right here, the probability of tails occurring? If I had a coin and I flipped it, what's the chance that it's going to land on tails? Well, there's only one tails out of two different sample spaces, so that's 1 out of 2, which is 1/2. That would be the theoretical probability. What's the probability of rolling a 3 if I had a number cube or a die? Well, there's only 1 3 out of 6 numbers, so my probability would be 1/6. What's the probability of 7 of diamonds being pulled out of a deck of cards? Well, there's only 1 7 of diamonds, so there'd be 1 out of 52 because there's 52 cards. And if you love those card games like I do, then you might know that there are 52. If not, then maybe not, but I'm telling you there are 52 in a deck. And my one favorite game, of course, is that 52 pickup. Have you played that game before? Well, if you haven't and someone wants to play with you, run. Run, I tell you. Okay, you can say, thank you, Mrs. McLean, for letting me know. Because what they're going to do is throw all 52 cards down on the floor and tell you to pick them up. That is 52 pickup. So, there is my one lovely word of advice for you. But if I'm looking at pulling an ace out of that deck of cards, well, there's 4 aces. So that would be 4 out of 52, which reduces to 1/13. I have a 1 out of 13 chance of pulling an ace. Now the next one is called probability model. And it's actually a model that helps us see. It provides the probability for each possible outcome. Kind of shows me what every possible outcome could be. And we're going to be looking at that in a minute. So let's go ahead and look at example 1, numbers 1 to 8. And that is if I have one fair number cube or one die and I'm rolling that die, what's the probability of each of these things occurring? What's the chance? So for number A, I put right there for you, what's the probability of not a 6? What's the probability that I will not get a 6? Well, the first step, you're going to make a ratio. The number of wanted outcomes is your numerator. Total possible is your denominator. Well, if I don't want a 6, that means I do want a 1, 2, 3, 4, or a 5. So that's 5 numbers. Out of 6 possible, my probability is 5/6. I can't simplify that anymore. But if I go ahead and look at B, it says what's the probability of less than 5? Well, the only numbers that are less than 5 are 1, 2, 3, and 4. Which means I have 4 that I do want to happen out of a possible 6 altogether. Now I can reduce that, and that would become 2 out of 3. So I have a 2/3 chance of rolling something less than 5. For C, if I said what's the probability of getting 2 or an odd number? Well, that means what I want it to be is a 1, 3, or 5, because those are odd. But I also don't mind if it's a 2. So again, there's only 4 numbers that I want out of a total of 6. So again, when I go ahead and reduce, that would be 2 out of 3. 2/3 of a chance. Now on the next one example, It's actually saying, well, what then if I don't roll one die? What if I roll two at the same time? What is that chance, or what's the probability of this occurring? It's basically the same directions as example 1. I need to know what is the probability that when I roll both die together, that I actually get and add up the two numbers on top, that the total will equal 3. So think about that. How many ways can I add to get a 3? I can add 1 plus 2, or I can, see, that's 3. Yep, 1 plus 2 is 3. Any other way. And out of how many? This is where people get stuck. Because quite honestly, I need to make sure that I draw a probability model. This is where that's going to come in so handy. And lucky for you, I've drawn one right below. So let's say I have those two number cubes. I have a green one and a red, just so you make sure that you understand. If I roll that green die could land on a 1. And the red one could land on a 1. But that only gives me a total of 2 when I look at this. So that's not. I could also have that green one land on a 1 and the red lands on a 2. Or the green could land on a 1 and it landed on a 3. Or the green landed on a 1 and the red landed on a 4. Or the green landed on a 1 and the red landed on a 5. Or the green landed on a 1 or the red landed on a 6. That's all the probabilities if the green landed on a 1. But what if the green landed on a 2? Or a 3? Or a 4? Or a 5? Or a 6? They're showing you right there every possible outcome I could ever hope to get when I rolled those die at the same time. So now let's go ahead and look and see how many give me when I add them together the total of 3. Well, there's a 1 plus a 2 and a 2 plus a 1. Those are the only two ways that I can get 3. So there are 2 possible ways to get a total of 3 out of 6, 12, 18, 24, 30. There are 36 possible outcomes if I roll 2 number die. Now, can I reduce it? I sure can. 2 goes into both. That means I have a chance, a 1 out of 18 chance of rolling 2 number cubes and getting the total shown to be a 3. Now here, let me show you why I love this probability model and how easy it makes it. What if I said, what is the probability that the total shown is going to give me larger, greater than 8? Well, let's go down to my chart and let's see if we can find out every number that is greater than 8 when I add them. So this would be 2, no. 3, no. 4, no. 5, no. 6, no. 7, no. There's nothing in that row that gives me bigger than 8. So here we got 3, 4, 5, 6, 7, 8. Oh, there's 8, but that's not greater than 8. There's nothing in that row. 4, 5, 6, 7, 8. Ah, finally, there's 1. 9. That one is 1. 5, 6, 7, 8. 9. Oh, and here's another one. 10. So far we've got 3 that will give me greater than 8. 6, 7, 8, 9, 10, 11. Perfect. 7, 8, 9, 10, 11, 12. There's all the possibilities of getting greater than 8 as a sum. So I have 1, 2, 3, and 4, which means when I add those all up, 3, 6, 10, I have 10 ways out of 36 possible outcomes. When I reduce it, divide by 2, I get 5/18. I have 5 out of an 18 chance of rolling 2 together, and I get a sum greater than 8. So you can see how that probability model really helps you see every possible outcome in order to figure out your answer. So again, write down any questions you have and bring them to class, and we will continue to